Tonight, we're going to witness the future of our entire world. Not tomorrow, not next year, not even in 1,000,000 years. We're going billions of years into the future, to a time when Earth no longer looks familiar, when the oceans are gone, the skies have changed forever, and the star that gave us life is reaching the end of its existence. For more than 4.5 billion years, the sun has been the engine of our solar system. Every sunrise in human history, every forest, every ocean, every living creature, all of it has depended on a single star. And yet, even the sun is living on borrowed time. Right now, deep inside its core, a slow process is unfolding, a process that cannot be stopped, a countdown that began long before the first humans walked the Earth. Most people imagine the death of a star as a sudden explosion, but the truth is far stranger. The sun will not die in a single moment. Its final chapter will unfold over billions of years. The transformation will be so vast that entire planets may disappear. Worlds will be consumed. The solar system itself will be changed forever. And what remains after the sun is gone may be even more fascinating than the star itself. Tonight, we'll travel across unimaginable stretches of time to witness the complete life cycle of our star. From the stable sun we know today, to the giant it will eventually become, and finally, to the silent stellar remnant that will drift through the darkness long after Earth is gone. To understand how the sun will die, we first need to understand how it lives. At this very moment, the sun is performing an extraordinary balancing act. Gravity is constantly trying to pull all of its matter inward. At the same time, nuclear fusion deep inside the core is pushing outward. These two forces have remained in balance for billions of years. Every second, the sun converts enormous amounts of hydrogen into helium. The process releases vast quantities of energy. That energy eventually reaches Earth. It warms our oceans, drives our weather, powers photosynthesis, and makes life possible. Without the sun, Earth would be a frozen and lifeless rock drifting through space. Yet even a star as massive as the sun cannot burn forever. Like a candle slowly consuming its wax, the sun is gradually using up the fuel that sustains it. The process is incredibly slow, so slow that from a human perspective, the sun seems completely unchanged. But over cosmic timescales, everything is changing. Millions of years from now, the sun will become slightly brighter, then brighter still. As the core slowly contracts, temperatures will rise. Fusion reactions will become more intense. The sun will produce more energy than it does today. At first, the changes will be subtle, but eventually they will transform Earth forever. Long before the sun reaches the end of its life, our planet will face a growing crisis. Rising temperatures will gradually alter the climate. The oceans will begin to evaporate. Water vapor will accumulate in the atmosphere. The greenhouse effect will intensify. Over vast periods of time, Earth's surface will become increasingly hostile. Plants will disappear. Animals will vanish. The complex ecosystems that have existed for hundreds of millions of years will come to an end. The Earth may survive, but life as we know it will not. As billions more years pass, the sun's hydrogen reserves will continue shrinking. Eventually, a critical threshold will be reached. The core will no longer be able to sustain fusion in the same way it does today. Gravity will begin winning the battle. The core will contract. Temperatures will soar. New fusion reactions will ignite in surrounding layers. And then the transformation will begin. The sun will start expanding, slowly, relentlessly, year after year, millennium after millennium. Its outer layers will stretch farther into space. The sun will become a red giant. From Earth, if anyone were there to witness it, the sight would be unimaginable. The sun would dominate the sky. Its glowing surface would appear vastly larger than it does today. Mercury would disappear completely. Venus would soon follow. The fate of Earth remains uncertain. Some models suggest that our planet could be swallowed by the expanding sun. Others indicate that Earth may drift outward slightly as the sun loses mass. But either way, the result is the same. The surface would be completely sterilized. The oceans would be gone. The atmosphere would be stripped away. Nothing familiar would remain. For a period of time, the red giant sun would be one of the most spectacular objects in the solar system. But even this phase is temporary. The sun is not massive enough to continue fusing heavier elements for long. Eventually, instability will take over. The outer layers will begin drifting away into space. Huge shells of gas will expand outward. These glowing clouds will form a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. They are the final breath of dying stars. For tens of thousands of years, the sun's discarded outer layers will shine across the solar system. The view would be breathtaking. Immense glowing clouds stretching across the darkness. Colors produced by energized gases. Expanding rings of material slowly fading into interstellar space. At the center of it all, something remarkable will remain. The core of the sun. No longer supported by fusion, no longer generating new energy. The core will collapse into a white dwarf. Although it will contain roughly half the sun's original mass, it will be compressed into a volume comparable to Earth. A single teaspoon of white dwarf material would weigh tons. The object will be incredibly dense, incredibly hot, and incredibly small compared to the giant star that once existed. For billions of years, the white dwarf will continue glowing. Not because it is producing energy, but because it is slowly releasing the heat stored during its former life. The cooling process will take longer than human minds can easily comprehend. Longer than the age of civilizations, longer than the age of continents, longer than the current age of the universe. Trillions of years may pass before the white dwarf becomes cold and dark. Astronomers call that hypothetical future object a black dwarf. But none exist today. The universe itself is not old enough. The first black dwarfs belong to a future so distant that even the Milky Way will have changed beyond recognition. And yet, the death of the sun is not a tragedy. It is part of a cycle that has shaped the universe from the very beginning. The atoms that make up our bodies were forged inside ancient stars that lived and died billions of years ago. The calcium in our bones, the oxygen we breathe, the iron in our blood, all of it was created in stellar furnaces. The death of stars makes new worlds possible. Without dying stars, there would be no planets, no oceans, no life, no humanity. In a very real sense, we are connected to stars that vanished long before the sun was born. And one day, the material from our own star may become part of something new, a future world, a future solar system, or perhaps something we cannot even imagine. The sun's death may seem unimaginably distant, but it reminds us of a profound truth. Nothing in the universe lasts forever. Not planets, not stars, not galaxies. Everything changes. Everything evolves. Everything eventually comes to an end. And as we continue our journey into the far future, we will discover that the death of the sun is only the beginning. Because beyond it lies an even greater story, the fate of every star in the cosmos, and ultimately, the fate of the universe itself. Billions of years after the sun is transformed into a white dwarf, the solar system will be almost unrecognizable. The vibrant planetary system we know today will be gone. The warm sunlight that once illuminated Earth will have faded to a faint glow. The great age of planets will be coming to an end, but the story does not stop there. Because even after stars die, their planets can continue their lonely journey through the darkness. For most of human history, planets have seemed permanent. Ancient civilizations watched them move across the night sky and assumed they would remain forever. Yet planets are far more fragile than they appear. Their existence depends on a delicate relationship with their parent star. When a star changes, everything around it changes as well. As the Sun expanded into a red giant, the inner solar system would have suffered catastrophic destruction. Mercury and Venus would almost certainly disappear. Earth may be consumed entirely or reduced to a barren remnant. Mars would become a scorched desert. The outer planets would survive longer, but they too would face a transformed environment. Jupiter, Saturn, Uranus and Neptune would continue orbiting the dying remains of the Sun. But the star they once orbited would no longer resemble the brilliant object that dominates our sky today. Instead, they would circle a small white dwarf, emitting only a fraction of its former energy. The solar system would become darker, colder, quieter. The giant planets would slowly lose what little warmth remained. Their atmospheres would continue evolving over unimaginable spans of time. The moons surrounding them would drift through an increasingly frozen cosmos. Some of these worlds might briefly experience unusual periods of change during the Sun's final stages. As the red giant expanded, distant icy moons could temporarily warm. Frozen oceans hidden beneath thick layers of ice might melt. For a brief moment in cosmic history, places that had remained frozen for billions of years could become active. But these moments would be temporary. Eventually, the cold would return, and it would continue growing. As trillions of years pass, another problem emerges: gravity. The solar system may appear stable, but its stability is not guaranteed forever. Every planet influences every other planet. The effect is tiny, almost imperceptible. Yet over billions and trillions of years, small gravitational disturbances can accumulate. Orbits can shift, worlds can wander. Some planets may eventually be thrown into entirely new trajectories. Others could be ejected from the solar system altogether. Astronomers believe that many rogue planets already drift through interstellar space. These worlds have no parent star, no sunrise, no sunset, only endless darkness. In the far future, some of the remaining planets of our solar system may share that fate. Imagine standing on a rogue planet, no star in the sky, no daylight, only distant points of light scattered across an increasingly empty universe. The planet continues moving, but it moves alone, without a home, without a sun, without a future. Even the surviving giant planets may not remain gravitationally bound forever. Encounters with passing stars could slowly disrupt the solar system. Over enough time, almost any configuration becomes possible. Entire worlds could be flung into deep space. Others could collide. Some might spiral inward toward the white dwarf that once was our Sun. The universe is patient. Given enough time, even the most stable systems can unravel. Yet planetary destruction is only part of the story. The universe itself is changing. The stars that illuminate distant galaxies are gradually disappearing. Star formation slows. Gas clouds become depleted. Fewer new stars are born. The brilliant era of stellar creation begins to fade. The future cosmos becomes a quieter place, a darker place, a lonelier place. Meanwhile, the white dwarf sun continues cooling. Its light grows dimmer with every passing billion years. Its surface temperature falls. Its glow weakens. The remnant that once sustained life on Earth becomes increasingly difficult to detect. Eventually, the white dwarf will no longer provide meaningful illumination to anything around it. The remaining planets, if any survive, will orbit through near total darkness. Imagine Neptune billions of years from now. The sky above it would be almost completely black. The sun would appear as little more than a faint stellar ember, a tiny reminder of a once great star. Time continues moving forward. Millions of years, billions, trillions. The distinction between day and night becomes meaningless. The planets become ancient relics, frozen monuments to a long-forgotten era. And yet, they continue orbiting, silent witnesses to the slow transformation of the cosmos. By this point, the universe itself is entering a new age. Many of the stars that exist today will already be gone. Galaxies will have evolved. Collisions between galaxies will reshape the cosmic landscape. The familiar night sky that humans once knew will have disappeared completely. If observers still exist somewhere in the far future, they may struggle to reconstruct the history of the universe. Evidence of its past will be fading away. The cosmos will become increasingly difficult to understand. And still, the surviving planets contain their journey. Cold, dark, ancient. Their story stretches far beyond the lifetime of their star. But even planets cannot survive forever. One by one, the great worlds of the universe will eventually disappear. Some will collide, some will be ejected, some will fall into stellar remnants. Others will simply wander endlessly through the darkness. The age of planets, like every age before it, must eventually come to an end. And when the last planets finally disappear, another chapter of cosmic history will begin. A universe ruled not by planets or stars, but by the strange and enduring remnants left behind after the stars are gone. For almost the entire history of the universe, stars have dominated the cosmos. They illuminated galaxies, forged the elements, powered planetary systems, and created the conditions necessary for life. But stars are not eternal. Even the longest-lived stars eventually exhaust their fuel. And as the universe ages, something remarkable begins to happen. The stars start disappearing. Not all at once, not through a single catastrophic event, but through a process so gradual that it unfolds across trillions of years. To understand this future, we need to look at the smallest stars ever formed, red dwarfs. These stars are very different from our Sun. They are smaller, cooler, and far more efficient. While the Sun is expected to live for around 10 billion years, many red dwarfs can survive for trillions of years. Some may continue shining for more than 10 trillion years. That is nearly 1,000 times longer than the Sun's entire lifespan. Today, red dwarfs are already the most common stars in the Milky Way. They make up the overwhelming majority of stars in our galaxy. Many of them were born billions of years ago. And long after stars like the Sun have vanished, red dwarfs will continue shining. In the distant future, they will become the dominant source of light in the universe. Imagine a cosmos where stars like the Sun no longer exist, where giant blue stars have disappeared, where supernova explosions have become increasingly rare. Only the small, dim red dwarfs remain. The night skies of future civilizations would look very different. The universe would appear quieter, older, more stable. Yet even these extraordinarily long-lived stars are slowly approaching their own endings. Unlike larger stars, red dwarfs burn their fuel with incredible efficiency. They mix hydrogen throughout much of their interiors. Almost nothing is wasted. For trillions of years, they continue converting hydrogen into helium, slowly, patiently, relentlessly. But eventually, even they begin to run out of fuel. And when that happens, the final era of starlight begins. One by one, the oldest red dwarfs start changing. Their brightness increases, their temperatures rise. For the first time in their unimaginably long lives, they begin moving toward death. Yet their deaths are surprisingly gentle. Most red dwarfs are too small to explode as supernovae. Instead, they gradually evolve into stellar remnants. The universe loses another source of light, then another, and another. The process takes place over timescales almost impossible to comprehend. Entire civilizations could rise and fall millions of times without noticing any significant change. But the change is happening, slowly, inevitably. As trillions of years pass, fewer active stars remain. The great stellar cities of the cosmos begin going dark. Galaxies that once contained hundreds of billions of shining suns become increasingly dim. The age of stars is ending. At the same time, star formation is coming to a halt. Throughout the history of the universe, giant clouds of gas have collapsed under gravity to create new stars. But these clouds are not infinite. Each new generation of stars consumes a portion of the available material. Eventually, the raw ingredients begin running out. Galaxies become depleted. The cosmic nurseries grow quiet. New stars become increasingly rare, then rarer still, until eventually almost no new stars are born at all. The universe enters a period astronomers sometimes call stellar degeneration. Not because stars suddenly disappear, but because the creation of new stars can no longer keep pace with the death of old ones. The balance shifts. The cosmos begins losing light faster than it gains it. Imagine observing the universe during this era. Across unimaginable distances, galaxies still exist, but they are darker than before. Their brightest stars have long vanished. Only faint stellar remnants remain. The great age of cosmic illumination is fading. And yet, for a time, red dwarfs continue resisting the darkness. They become the final guardians of starlight, the last ordinary stars in existence. If intelligent life survives into this distant future, red dwarfs may become extraordinarily valuable. Entire civilizations could gather around them, protect them, depend upon them, because each remaining star represents a precious source of energy in an increasingly cold universe. But even the last red dwarfs cannot live forever. One by one they exhaust their fuel. One by one they fade away. The process may take tens of trillions of years, perhaps even longer, yet the outcome never changes. Eventually, the final red dwarf reaches the end of its life. For the first time since the earliest days of cosmic history, there are no ordinary stars left, no new sunrises, no shining stellar disks, no brilliant constellations. The universe becomes a place dominated by remnants, white dwarfs, neutron stars, black holes, ancient objects left behind by stars that once illuminated the cosmos. The disappearance of the last red dwarf marks one of the greatest turning points in the history of the universe. For billions of years, stars defined reality. Now they are gone. Darkness becomes the dominant feature of the cosmos. The age of stars is over. But surprisingly, the universe is far from dead. Some of its strangest chapters are only beginning. Because after the last stars disappear, countless stellar remnants continue wandering through space. And among them are some of the most extreme objects ever created. Objects so dense that a single spoonful would outweigh mountains. Objects with magnetic fields powerful enough to tear atoms apart. Objects capable of bending space and time itself. In the next chapter, we journey into a universe where ordinary stars no longer exist. A universe ruled by the strange and mysterious remnants known as neutron stars. The universe is now older than anything we can easily imagine. The last ordinary stars have vanished. The familiar glow that once filled galaxies has faded into history. No more sunrises, no more stellar nurseries, no more brilliant constellations stretching across the night sky. The age of stars has come to an end. Yet the universe is not completely dark. Scattered throughout the cosmos are the remnants left behind by countless generations of dead stars. White dwarfs drift silently through space. Black holes lurk in the darkness. And among the strangest objects of all are neutron stars. These extraordinary remnants were born from some of the most violent events in cosmic history. Long ago, when massive stars exhausted their fuel, they collapsed under their own gravity. The collapse happened so quickly that entire stars imploded in a matter of seconds. The resulting explosion, known as a supernova, released enormous amounts of energy. For a brief moment, a dying star could outshine an entire galaxy. But after the explosion, something remarkable remained. The core, a neutron star. These objects are unlike anything humans experience in everyday life. A neutron star may contain more mass than our sun, yet it is compressed into a sphere only about 20 kilometers across. Imagine taking an object larger than a star and crushing it until it becomes the size of a city. The result is almost beyond comprehension. Matter inside a neutron star exists under extreme conditions. Atoms no longer resemble atoms. The familiar structure of matter breaks down. Protons and electrons merge together. What remains is an ocean of neutrons, packed so tightly that a single teaspoon of neutron star material would weigh billions of tons. If such material could somehow be brought to Earth, its mass would exceed that of entire mountains. Gravity on the surface of a neutron star is equally astonishing. A person standing there would be crushed instantly. Not even the strongest materials known could survive. The escape velocity is so high that light itself struggles to leave the surface. And yet, neutron stars are not simply dense. Many are also incredibly powerful. Some rotate hundreds of times every second. Imagine an object more massive than the sun, spinning faster than a kitchen blender. The energy involved is extraordinary. These rapidly rotating neutron stars are known as pulsars. As they spin, they emit beams of radiation from their magnetic poles. If one of these beams sweeps across Earth, astronomers observe regular pulses of energy, like the beam of a lighthouse crossing a distant shore. Some pulsars are so precise that they rival the accuracy of atomic clocks. For decades, they have served as natural cosmic timekeepers. But in the far future, even pulsars begin to change. Their rotation slowly slows. Energy is lost. The pulses weaken. Over trillions of years, they become quieter, dimmer, older, like ancient machines gradually winding down. Yet neutron stars possess another remarkable feature: their magnetic fields. Some neutron stars, known as magnetars, generate the strongest magnetic fields ever discovered in the universe. These fields are so powerful that they can distort atomic structures themselves. If a magnetar passed too close to Earth, its magnetic field could disrupt matter at the molecular level. Fortunately, such encounters are extremely unlikely. Still, magnetars remind us that even among stellar remnants, there exists incredible diversity. The future universe contains countless examples of these extraordinary objects. Some travel alone through interstellar space. Others remain locked in gravitational dances with companion remnants. Occasionally, two neutron stars may collide. When this happens, one of the most energetic events in the universe unfolds. The collision releases vast quantities of energy. Ripples spread through space-time itself. Heavy elements are forged: gold, platinum, and many of the rare elements that once enriched planets and civilizations. Even in death, stars continue shaping the cosmos. As the universe ages further, neutron stars become increasingly common. Not because new ones are being created, but because so many other objects have already disappeared. The universe is becoming a graveyard of stellar remnants, a vast collection of ancient objects drifting through expanding darkness. Yet neutron stars do not last forever. Nothing does. Given enough time, they too begin changing. Some may slowly cool, others may merge with companions. A few may encounter black holes and disappear entirely. The future is measured not in millions or billions of years, but in trillions upon trillions. Timescales so immense that entire galactic histories become insignificant. Through all of this, the universe grows darker. The remaining sources of light become increasingly rare. The distance between active objects grows larger. Silence spreads across the cosmos, and eventually even neutron stars lose their dominance. Because there is another type of remnant waiting patiently in the darkness. A remnant far stranger than any neutron star. an object with gravity so powerful that nothing can escape once it crosses a certain boundary. Not light, not matter, not information, black holes. As the universe continues aging, these mysterious objects will become increasingly important. They will consume remnants, shape galaxies, and eventually inherit a universe abandoned by the stars. The age of neutron stars is only a transition, a brief chapter in a much longer story, because the next era belongs to the darkest objects ever created, an era when black holes become the undisputed rulers of the cosmos. The universe has entered a new age. The stars are gone. The last red dwarfs have faded into darkness. Neutron stars drift through space like ancient relics from a forgotten era. Yet among all the remnants left behind by stellar evolution, one type of object now dominates the cosmos: black holes. For billions of years, black holes captured the imagination of scientists and dreamers alike. They were once considered cosmic monsters, invisible traps from which nothing could escape, even light itself. But in the far future, black holes become far more than mysterious objects. They become the architects of the universe. To understand why, we must first understand what a black hole truly is. A black hole forms when gravity overwhelms everything else. Matter collapses inward, space itself bends. Eventually, a boundary forms. Astronomers call it the event horizon. Cross this invisible surface and there is no return. Not because something is physically pulling you back, but because every possible path through space-time leads deeper inside. Beyond the event horizon, escape becomes impossible. For much of cosmic history, black holes existed alongside stars. Some were born from dying massive stars. Others grew over billions of years inside galaxies. At the centers of many galaxies lurked supermassive black holes, containing millions or even billions of times the mass of our Sun. These giants shaped the evolution of entire galactic systems. Even today, the center of the Milky Way contains such an object, a supermassive black hole known as Sagittarius A star. Yet, compared to the future, the black holes we observe today are merely the beginning. As stars disappear and galaxies evolve, black holes inherit more and more of the universe's mass. They consume gas, they absorb dust, they swallow wandering planets, they capture white dwarfs and neutron stars. Slowly but relentlessly, they grow. The process unfolds across unimaginable timescales. Trillions of years pass, then quadrillions. The universe becomes increasingly empty. The brilliant structures that once filled the cosmos begin fading away. But black holes remain. Their gravity continues shaping whatever matter survives. Some black holes merge with one another. When two black holes collide, space itself trembles. Gravitational waves ripple outward across the universe. The newly formed black hole becomes even larger, even more powerful. Across countless ages, these mergers continue. The population of black holes decreases, but the survivors become increasingly massive. Imagine observing the universe during this era. There are no ordinary stars, no familiar galaxies, only darkness, interrupted by occasional encounters between ancient remnants. And at the center of many surviving structures sit enormous black holes, silent, invisible, patient, waiting. Unlike stars, black holes require no fuel. They do not burn hydrogen. They do not depend on nuclear fusion. As long as matter exists to fall into them, they can continue growing. This gives black holes an incredible advantage in the aging universe. Everything else is slowly running out of energy. Everything else is fading. But black holes endure. For an observer living in this distant future, black holes may appear almost eternal. Entire cosmic eras pass without significant change. The universe grows colder. The distances between objects grow larger. Expansion continues, stretching space itself. Galaxies become isolated islands, separated by unimaginable voids. Eventually, many galaxies disappear beyond one another's observable horizons. The universe becomes lonelier than ever before, yet black holes remain. They are among the last major structures left. Their influence extends across vast distances. Their gravity continues pulling in whatever remnants wander too close. Rogue planets, white dwarfs, neutron stars. Everything becomes potential fuel, and as the black holes grow, they become the dominant engines of cosmic evolution. In some regions of the future universe, entire systems may consist of little more than black holes orbiting one another. No light, no warmth, only gravity. A silent dance unfolding across the darkness. To us, this future sounds bleak, but from the perspective of the universe, it is simply another chapter in an endless story of transformation. The age of black holes may last longer than every previous cosmic era combined, far longer than the age of stars, far longer than the existence of planets, far longer than the history of galaxies as we know them. Black holes become the longest-lasting rulers the cosmos has ever known. And yet, even they are not immortal. For centuries, scientists believed black holes would last forever. They seemed indestructible. Once formed, nothing could destroy them. At least that was the assumption. Then came one of the most surprising discoveries in modern physics, a discovery that completely changed our understanding of black holes. According to quantum theory, black holes are not entirely black. They slowly emit tiny amounts of radiation, an effect now known as Hawking radiation. The process is almost unimaginably slow. For black holes that exist today, the energy released is insignificant, far smaller than anything we could easily detect. Yet over sufficiently long timescales, the consequences become extraordinary. A black hole slowly loses mass, very slowly, so slowly that the process is irrelevant over billions or even trillions of years. But given enough time, the impossible begins to happen. The black hole starts evaporating. The greatest survivors of the cosmos are not truly eternal after all. The kings of the universe have a lifespan, and one day, even they will disappear. The age of black holes may dominate the future, but it too must eventually come to an end. And when the first black holes begin their long evaporation, the universe will enter one of the strangest eras in its entire history. An era where the last giants slowly fade into nothingness. An era where even darkness begins to disappear. For longer than any civilization could possibly imagine, black holes ruled the universe. They outlived stars, they outlived planets, they outlived galaxies as they once existed. While everything else faded into darkness, black holes endured. To any observer living during the age of black holes, they would appear eternal, unchanging, immortal. But appearances can be deceiving. Deep within the fabric of reality, an invisible process has been unfolding since the very moment each black hole formed. A process so slow that entire cosmic eras pass unnoticed. A process that will eventually erase the most powerful objects in the universe. This is the era of black hole evaporation. To understand why black holes eventually disappear, we must explore one of the strangest ideas in modern physics, quantum mechanics. In our everyday lives, empty space appears truly empty, a perfect vacuum, a place where nothing exists. But according to quantum theory, empty space is never actually empty. Even the darkest regions of the universe contain tiny fluctuations of energy. Particles constantly appear and disappear. They emerge from the vacuum itself, exist for an incredibly brief moment, then vanish again. This strange behavior occurs everywhere, even near a black hole, and that changes everything. Near the event horizon, these quantum fluctuations can produce an unexpected result. Occasionally, one particle falls into the black hole, while the other escapes into space. To a distant observer, it appears as though the black hole is emitting radiation. This phenomenon became known as Hawking radiation, named after physicist Stephen Hawking, who first described the process in the 1970s. The discovery shocked the scientific community. For decades, black holes had been viewed as objects that could only grow. Now physicists realize something extraordinary. Black holes can also lose energy, and when energy leaves, mass leaves with it. The black hole begins shrinking. The process is unbelievably slow. A stellar black hole may take far longer than the current age of the universe to lose even a tiny fraction of its mass. For supermassive black holes, the timescales become almost incomprehensible. Trillions of years are not enough. Quadrillions are not enough. Even quintillions of years barely matter. The evaporation process unfolds across spans of time so vast that human language struggles to describe them. Yet the outcome remains unavoidable. Every black hole is slowly disappearing. Imagine the universe during this distant era. The stars are gone, the planets are gone, neutron stars have become rare. Most ordinary matter has either decayed, been consumed, or drifted into the darkness. The universe is colder than ever before, larger than ever before, and almost entirely silent. Scattered throughout this immense emptiness are black holes, the final giants of creation, each one slowly losing mass, each one moving toward its inevitable end. For unimaginable lengths of time, nothing seems to happen. A black hole that contains billions of solar masses changes so slowly that entire cosmic ages pass without noticeable difference. Yet the evaporation continues. Particle by particle, photon by photon, energy escapes, mass decreases, the black hole shrinks. As it becomes smaller, something surprising occurs. The evaporation process accelerates. A smaller black hole emits more radiation, which causes it to lose mass faster, which makes it even smaller. The cycle continues, slowly at first, then more rapidly. The final moments of a black hole's life are unlike anything that came before. After spending unimaginable ages, fading almost imperceptibly, the black hole suddenly enters its last stage. The evaporation becomes intense, energy pours into space, the object rapidly shrinks, and then, in an instant, it is gone. No explosion comparable to a supernova, no dramatic collapse, simply the final release of its remaining energy. The black hole ceases to exist. One of the most powerful objects ever created vanishes forever. Now imagine this process happening across the universe. One black hole disappears, then another and another. The great cosmic rulers begin falling. The giants that survived every previous age finally reach their limits. For the first time in trillions upon trillions upon trillions of years, the universe begins losing its black holes. The transformation is profound. For eons, black holes dominated the cosmos. Now even they are fading away. The universe is running out of structure, running out of complexity, running out of energy. The darkness becomes deeper. The emptiness grows larger. Eventually, only the largest black holes remain. These ancient titans are the last survivors of an already ancient universe. They continue evaporating for timescales so enormous that even the concept of history becomes meaningless. Civilizations, stars, galaxies, and black holes all belong to a distant past. Only the final remnants remain. Then comes the moment, the last black hole, the final ruler of the cosmos. For longer than any object before it, it survives, alone, surrounded by a universe almost entirely devoid of activity. Its evaporation continues, slowly, relentlessly, until eventually, even it reaches the end. The final black hole disappears, and with its disappearance, one of the greatest eras in cosmic history comes to a close. The age of black holes is over. No stars remain, no planets remain, no black holes remain. The universe enters a state unlike anything that existed before, a cosmos almost entirely empty, a cosmos where matter itself becomes increasingly rare, a cosmos approaching absolute stillness. Yet the story is not finished, because after the last black hole vanishes, something even stranger awaits. The universe enters its darkest chapter, a chapter where almost nothing happens, a chapter known as the Dark Era. And in that endless darkness, the ultimate fate of reality begins to unfold. For countless ages, the universe has drifted through darkness. The stars are gone, the planets are gone, the black holes have evaporated. Even the remnants of matter are becoming increasingly rare. Space stretches endlessly in every direction, silent, cold, empty. To most observers, this would appear to be the end of the story, the final chapter, the ultimate fate of reality. Yet some of the strangest ideas in modern physics suggest that the universe may still have one more surprise waiting in the darkness. To understand this possibility, we must explore the nature of the vacuum itself. When most people think of empty space, they imagine nothing, a perfect void, a place completely devoid of matter and energy. But physics tells a different story. The vacuum is not truly empty. It possesses energy. Invisible fields permeate every region of space. Quantum fluctuations continuously emerge and disappear. What appears empty is actually an incredibly complex foundation underlying reality itself. And this raises an unsettling question. What if the vacuum state we currently inhabit is not the lowest possible state? What if our universe exists in a temporary condition, a kind of cosmic balance that only appears stable? Imagine a ball resting in a shallow valley. At first glance it seems secure, motionless, permanent. But hidden beyond a nearby hill lies a much deeper valley. If the ball somehow crosses that barrier, it would roll downward into a completely different state. Some physicists believe the universe itself may exist in a similar situation. The vacuum of space could be what is known as a false vacuum, stable for now, but not truly permanent. If this idea is correct, an extraordinary event could occur. At some point in the distant future, a tiny region of space might transition into a lower energy state, a new vacuum, a more stable version of reality. The consequences would be unlike anything that has happened before. The transition would create an expanding bubble. Inside that bubble, the laws of physics themselves could be different. The strengths of fundamental forces might change. The properties of particles could change. Atoms might no longer exist in their current form. Matter, as we know it, could become impossible. The bubble would expand outward at nearly the speed of light, consuming everything in its path. Stars, galaxies, black holes, planets, civilizations, entire cosmic structures. Everything would be transformed. And the most remarkable part is that no warning would be possible. Because the bubble travels at the speed of light, nothing ahead of it could detect its approach. Observers would not see it coming. There would be no alarm, no final message. One moment, reality would appear normal. The next, everything would be different. Fortunately, there is no evidence that such an event is imminent. In fact, if vacuum decay is possible, the universe may remain stable for periods vastly longer than any timescale we have discussed. Perhaps longer than the age of black holes. Perhaps longer than the Dark Era itself. The important point is not when it might happen. The important point is that the ultimate future of the universe may be far less certain than it appears. And vacuum decay is only one possibility. Other theories propose even stranger futures. Some suggest that entirely new universes could emerge from quantum fluctuations, tiny regions of space where conditions allow a new cosmic expansion to begin, a new Big Bang, a new beginning. From the perspective of the parent universe, these events would be almost impossible to observe. Yet they could represent the birth of entirely new realities, new stars, new galaxies, new histories, new civilizations. Perhaps, somewhere in the endless future, countless universes are born from the remains of older ones. A cosmic cycle, stretching beyond anything humans have ever imagined. Then there is another possibility. Perhaps the universe continues forever. No dramatic ending, no vacuum decay, no final collapse, only eternal expansion. Space grows larger, particles drift farther apart, activity becomes increasingly rare, reality gradually approaches perfect stillness. A universe that never truly dies, but never truly changes again. The truth is that no one knows which future awaits. Our understanding of physics remains incomplete. The deepest questions about space, time, and existence are still unanswered. What we do know is that the future stretches far beyond anything humans normally imagine, far beyond the lifespan of stars, far beyond the lifespan of galaxies, far beyond the lifespan of black holes. The universe is far older, far larger, and far stranger than our everyday experience suggests. Every chapter we have explored has revealed a different transformation. The death of the sun, the disappearance of planets, the fading of stars, the rise of black holes, the dark era. Each stage seemed like an ending, yet each led to something new, something unexpected. And perhaps that is the greatest lesson the cosmos has to offer. Endings and beginnings are often difficult to distinguish. What appears to be the end of one era may simply be the start of another. Somewhere in the unimaginable future, beyond the reach of stars and galaxies, reality may still be evolving, still changing, still creating possibilities we cannot yet comprehend. The universe has surprised us before. It may do so again. And as we stand here today, beneath the light of a living star, surrounded by a universe filled with wonder, one truth remains clear. The story of the cosmos is far from simple, and perhaps it is far from over. The universe has entered its darkest age. The stars are gone, the planets are gone, the galaxies that once filled the cosmos with light have faded into obscurity. Even the last black hole has evaporated. For the first time since the birth of the universe, there are no longer any great cosmic structures remaining. No brilliant suns, no glowing nebulae, no supermassive black holes anchoring ancient galaxies. Only darkness, endless darkness. If a conscious observer could somehow exist during this era, the universe would appear almost completely empty. There would be no familiar landmarks, no constellations, no glowing bands of stars stretching across the sky. In every direction, there would be only an immense and silent void. This is the Dark Era, a period so vast that all previous chapters of cosmic history seem brief by comparison. Everything humanity has ever known occupies only a tiny fraction of the universe's lifespan. The entire history of civilization, the rise and fall of stars, the formation of galaxies, the age of black holes, all of it becomes little more than a fleeting moment in comparison to the unimaginable duration of the Dark Era. Yet even now, the universe is not completely empty. Scattered throughout the darkness remain tiny remnants of matter, subatomic particles drifting through an ever-expanding cosmos. Electrons, positrons, photons, neutrinos, the leftover fragments of a universe that was once filled with complexity and light. These particles are separated by distances so vast that encounters become exceedingly rare. The universe continues expanding. The gaps between particles grow larger. Space itself stretches relentlessly. Every passing age makes the cosmos more dilute, more empty, more silent. In this future, events become extraordinarily uncommon. Entire stretches of time may pass without anything noteworthy occurring. 1 trillion years, then another trillion. Then numbers so large that ordinary language loses its meaning. The universe approaches a state of near-perfect stillness. And yet, quantum physics refuses to allow absolute silence. Even in the deepest darkness, reality remains restless. Tiny fluctuations continue occurring throughout space. The vacuum itself is not truly empty. Invisible processes continue unfolding beneath the surface of existence. Most are insignificant, but given enough time, even the rarest events become inevitable. Imagine shuffling a deck of cards forever. Eventually, every possible arrangement will appear. The same principle applies to the universe. The dark era lasts so long that extraordinarily unlikely events may eventually occur. Particles that have drifted alone for unimaginable spans of time may encounter one another. New structures could briefly form. Tiny flashes of activity could emerge within the darkness. These events would be exceedingly rare, separated by incomprehensible intervals, but they remain possible. The universe has become a place governed by patience, a place where even the smallest event may require timescales beyond imagination. Some physicists believe that protons themselves may not be eternal. The proton is one of the fundamental building blocks of ordinary matter. Every atom in your body contains them. Every planet that ever existed was built from them. For much of scientific history, protons were assumed to be stable forever. Yet some theories suggest otherwise. If proton decay is real, then even the remaining matter of the universe has an expiration date. The process would be incredibly slow, far slower than the evaporation of black holes, but eventually protons could break apart into lighter particles. If that happens, one of the last forms of organized matter disappears. The universe becomes even simpler, even emptier. The remnants of stars and planets finally dissolve into fundamental particles. The cosmos approaches a state of maximum entropy, a state where energy is spread almost perfectly evenly throughout space. This concept is often called heat death. Despite its dramatic name, it is not an explosion, not a catastrophe, not a sudden ending. It is simply the gradual exhaustion of usable energy. Everything that can happen has largely happened. Everything that can decay has largely decayed. The universe settles into an almost featureless condition. For many scientists, this represents the ultimate fate of reality, an endless future of darkness and stillness, a cosmos where meaningful change becomes nearly impossible. Yet the story may not end there. Because the deeper physicists explore the nature of reality, the more mysterious the future becomes. Some theories suggest that quantum fluctuations could occasionally produce surprising structures. Others hint at entirely new forms of physics waiting beyond our current understanding. And then there is an even stranger possibility. What if the universe itself is not eternal? What if the vacuum of space is not as stable as it appears? What if reality is resting on a foundation that could one day change? The dark era may seem like the end, but hidden within its endless silence may lie the seeds of something even more extraordinary. A transformation unlike anything that came before. A possibility so strange that it challenges our understanding of existence itself. Because after the stars, after the planets, after the black holes, after the darkness, there may still be one final chapter left to tell. If the universe truly continues into the far future, then one question becomes impossible to ignore. Will anything survive forever? We have watched stars die. We have watched planets disappear. We have witnessed the rise and fall of black holes. Even matter itself may eventually decay. Again and again, the universe seems to deliver the same message: nothing lasts forever. And yet, when physicists explore the deepest laws of nature, the answer becomes less certain than it first appears. Because while almost everything we know is temporary, some things may endure far longer than we can comprehend. The first candidate is space itself. Throughout the history of the universe, stars have changed, galaxies have evolved, matter has transformed, but space has remained. The vast cosmic stage upon which every event unfolds. Even as the universe expands, space continues existing, growing larger, stretching farther, creating ever greater distances between the remaining particles. If the universe expands forever, space itself may outlive everything else. Long after the last star has faded and the last black hole has evaporated, the fabric of space-time could remain, silent, empty, yet still present. Then there is energy. One of the most fundamental principles in physics is the conservation of energy. Energy cannot be created or destroyed. It can only change form. Throughout cosmic history, energy has taken many shapes. Light from stars, heat from planets, radiation from black holes, motion of galaxies. But as the universe ages, usable energy becomes increasingly scarce. Energy does not disappear. It simply becomes spread out, more uniform, more difficult to use. This gradual process drives the universe toward maximum entropy, the state often referred to as heat death. In this future, energy still exists, but it becomes almost impossible to harness, like a vast ocean with no waves, present yet motionless, potentially eternal, but effectively silent. There is also the possibility that some particles survive far longer than others. Electrons, for example, appear remarkably stable. Unlike many other particles, no evidence suggests that electrons decay. If this remains true, electrons could persist through unimaginable stretches of time, drifting through the darkness long after every familiar structure has vanished. Tiny survivors of a universe that once contained stars and civilizations. Yet even these possibilities may not represent true immortality, because the universe itself could still change. Modern physics contains many unanswered questions. Questions about dark energy, questions about quantum gravity, questions about the ultimate nature of space and time. Our current understanding may be incomplete. Future discoveries could reveal processes that alter everything we think we know about permanence. Perhaps even space itself is temporary. Perhaps reality contains hidden transitions waiting to unfold. The truth remains uncertain. But there is another fascinating possibility: information. Some physicists believe that information can never be completely destroyed. This idea emerged from studies of black holes and quantum mechanics. Even when objects disappear, information about their existence may remain encoded within the universe in ways we do not yet fully understand. If this is true, then traces of everything that has ever existed may survive indefinitely. The stars, the planets, the galaxies, even us, not as living beings, not as physical structures, but as information woven into the fabric of reality. The concept is both comforting and mysterious. Perhaps nothing survives forever in the form we recognize, yet perhaps nothing is ever completely lost. Every event leaves a mark. Every interaction contributes to the evolving story of the cosmos. And that story may persist long after the objects themselves have disappeared. Now imagine standing at the edge of the far future. The stars are gone. The galaxies have faded. Black holes no longer exist. Matter has become extraordinarily rare. The universe is almost silent, almost empty, almost motionless. Yet scattered throughout the darkness remain faint reminders of everything that came before. Particles, radiation, information, tiny echoes of a once vibrant cosmos. In many ways, this future represents the ultimate triumph of time. Time defeats stars. Time defeats planets. Time defeats galaxies. Time defeats black holes. Given enough of it, almost every structure, eventually yields. And yet time itself continues, flowing onward, without urgency, without destination, without end, at least as far as we currently understand. Perhaps that is what makes the future of the universe so extraordinary. Not its violence, not its destruction, but its patience. The universe does not rush toward its fate. It unfolds slowly, across timescales so vast that entire cosmic eras become fleeting moments. And through it all, one question remains. If everything changes, if everything eventually disappears, what does it truly mean to exist? The stars answered that question with light. The planets answered it with life. The black holes answered it with gravity. But perhaps the final answer lies somewhere beyond them all, hidden within the endless future, waiting in the darkness, waiting at the very edge of time itself. And that brings us to the final chapter of our journey. A chapter where we step beyond the death of stars, beyond the evaporation of black holes, and beyond even the limits of known physics. A chapter where we ask the ultimate question: what happens after the end? And now we arrive at the edge of everything. Not the edge of a galaxy, not the edge of a star system, not even the edge of the observable universe. We stand at the edge of time itself. Behind us lies a history almost impossible to comprehend. The birth of stars, the formation of planets, the emergence of life, the rise of civilizations, the death of suns, the evaporation of black holes, the long descent into darkness. Every chapter of cosmic history has already unfolded. Every great structure has come and gone. The universe that once sparkled with countless galaxies has become a place of silence, a place where change is almost impossible to detect. And yet, even here, one final question remains. What happens after the end? At first, the question seems impossible. How can anything happen after the end of everything? But the answer depends on what we mean by the end. Throughout this journey, we have discovered that endings are rarely absolute. The death of a star led to the birth of stellar remnants. The disappearance of planets gave way to new cosmic eras. Even black holes, once thought eternal, eventually faded away. Again and again, the universe transformed itself. Each ending became the beginning of something new. So perhaps the ultimate fate of reality is not an ending at all. Perhaps it is another transformation waiting beyond our understanding. One possibility is that the universe simply continues forever. Expansion never stops. Space grows larger. Distances become greater. The remaining particles drift farther apart. The cosmos approaches perfect emptiness, not because something destroys it, but because everything becomes increasingly isolated. The universe does not die, it simply grows quieter, older, colder, forever. In this future, time continues without limit. 1 trillion years passes, then another trillion, then numbers so vast that human language can no longer describe them. Yet nothing significant changes. Reality enters an eternal stillness, a state where existence continues, but events become almost non-existent. It is a future both beautiful and unsettling, a universe that survives, but never awakens again. Yet some theories suggest a more dramatic possibility. What if our universe is only one chapter in a much larger story? Modern cosmology has revealed that the universe began in an event we call the Big Bang. Space expanded, matter formed, stars ignited. Everything we know emerged from that beginning. But what caused it? What came before? No one knows. Some scientists propose that new universes may continuously emerge, each with its own laws, its own history, its own stars and galaxies. If that is true, then perhaps the death of one universe is connected to the birth of another. Perhaps reality is not a single story. Perhaps it is an endless collection of stories unfolding across unimaginable scales. Some universes may be born, Others may fade away, the process continuing far beyond anything we can observe. Then there are theories even stranger, ideas suggesting that space and time themselves are not fundamental, that reality may emerge from deeper structures we do not yet understand. If those ideas are correct, then the future could hold possibilities completely beyond our imagination. Just as ancient civilizations could not have imagined black holes or distant galaxies, we may be unable to imagine what lies beyond the final horizons of physics. Perhaps there are transformations waiting that no human mind has ever conceived. Possibilities hidden behind the limits of current knowledge. Mysteries that remain invisible to us today. And maybe that is the most important lesson of all. The universe has repeatedly surprised us. For thousands of years, humanity believed Earth was the center of everything. We were wrong. Then we believed our galaxy was the entire universe. We were wrong again. Later, we thought black holes were impossible. Then we discovered they were real. Again and again, reality proved larger than our assumptions, stranger than our expectations, more beautiful than our imaginations. Why should the future be any different? Why should the final chapters of cosmic history be any less surprising than the first? Perhaps the end of the universe is not something to fear. Perhaps it is simply another mystery, another horizon waiting to be explored, another question without an answer. And maybe there is something comforting in that. The fact that the universe remains unfinished, that even after centuries of discovery, the greatest questions still remain open. What is dark energy? Why does the universe exist? Is space infinite? Are there other universes? What happens after the end? Today, we do not know. And that uncertainty is part of the wonder, because every unanswered question represents a frontier, a place where curiosity can still travel, a place where imagination can still wander. As we conclude this journey through the far future, one thing becomes clear. The universe is not merely a collection of stars and galaxies, it is a story. A story that began billions of years ago, a story that continues today, and a story that may continue long after every star has vanished from the sky. We are fortunate enough to exist during one brief moment of that story, a moment when the stars still shine, when planets still orbit, when life still thrives beneath the light of a living sun. The future may be dark, the future may be empty, the future may be strange beyond comprehension, but for now, the universe is alive, and perhaps that is the most extraordinary fact of all. Because somewhere between the beginning and the end, between the birth of stars and the fading of time, the universe became aware of itself, through us. And as long as we continue looking up at the night sky, wondering what lies beyond the next horizon, the story is not over. Not yet. We have traveled from the birth of stars to the death of the universe. We have crossed billions, trillions, and even unimaginable stretches of time. We have witnessed galaxies forming, stars igniting, planets emerging, black holes consuming entire regions of space, and eventually the slow fading of everything. Yet after all of this, one mystery remains untouched, perhaps the greatest mystery of all. Why does anything exist in the first place? It is a question so simple that a child can ask it, and so profound that the brightest minds in history have struggled to answer it. Why is there something rather than nothing? At first glance, the question seems strange. After all, existence is all we have ever known. The universe is here, the stars are here, we are here. But when we look deeper, the mystery becomes impossible to ignore. Nothing in our understanding of physics fully explains why reality exists at all. Science can describe how the universe evolved. It can explain how stars form, how galaxies grow, how planets emerge. But the question of why there is a universe in the first place remains open. The Big Bang is often described as the beginning of everything, but was it truly a beginning, or merely the beginning of the universe as we know it? The answer is uncertain. When we trace cosmic history backward, we eventually reach a point where our current theories break down. Temperatures become infinite, densities become extreme. Space and time themselves behave in ways we do not yet understand. Beyond that boundary, our knowledge fades into speculation. Some theories suggest that time itself began with the Big Bang. If that is true, asking what happened before the Big Bang may be like asking what lies north of the North Pole. The question itself may not have meaning. Yet other theories propose a different possibility. Perhaps the Big Bang was not the absolute beginning. Perhaps it emerged from an earlier state, a previous universe, a quantum fluctuation, a cosmic cycle repeating across eternity. The possibilities are numerous, and none have yet been confirmed. This uncertainty reveals something important. For all our scientific achievements, there are still questions beyond our reach. Questions that sit at the very edge of human understanding. Questions that may remain unanswered for generations to come, or forever. And yet, there is something beautiful about that. Mystery has always driven discovery. Every great breakthrough began with uncertainty. Every scientific revolution began with a question. The unknown is not a barrier. It is an invitation to keep exploring, to keep learning, to keep asking. Imagine humanity thousands of years from now. Perhaps our descendants will understand the universe far better than we do. Perhaps they will solve mysteries that seem impossible today. Perhaps they will uncover the true nature of dark matter, the true nature of dark energy, the origin of space and time. The reason the laws of physics have the values they do, or perhaps every answer will reveal new questions waiting beyond it, a horizon that forever moves farther away. The history of science suggests exactly that. The more we learn, the more we discover how much remains unknown. Every solved mystery reveals deeper mysteries beneath it. Every new discovery expands the boundaries of wonder. Perhaps there is no final answer. Perhaps understanding is not a destination. Perhaps it is a journey, a never-ending process of exploration. And if that is true, then the future of knowledge may be as vast as the future of the universe itself. Because curiosity is one of the most remarkable forces in existence. It has carried humanity from caves to cities, from myths to mathematics, from staring at the stars to landing on other worlds. Curiosity transformed a species living on a small planet into a species capable of studying galaxies billions of light years away. It allowed the universe to become aware of its own history, its own structure, its own future. And perhaps one day it will allow us to understand even more. Or perhaps some mysteries will remain forever beyond reach. Either possibility is extraordinary, because both remind us of how vast reality truly is. The universe does not owe us answers, yet it offers us questions. And sometimes the questions are even more valuable. As our journey nears its conclusion, it is worth reflecting on the unlikely chain of events that brought us here. A universe emerged, stars formed, heavy elements were forged, planets appeared, life evolved, conscious minds awakened. And eventually those minds began asking, why? The fact that such a sequence occurred at all may be one of the most astonishing facts in existence. We often focus on how large the universe is, how old it is, how powerful its forces are. But perhaps the most extraordinary thing about the cosmos is that it produced beings capable of wondering about it. Beings capable of tracing its history from the Big Bang to the far future. Beings capable of imagining what lies beyond the limits of observation. And that brings us to the final chapter. Not a chapter about stars, not a chapter about galaxies, not a chapter about physics, but a chapter about perspective, about what our brief moment in cosmic history truly means. Because after exploring the entire future of the universe, one final question remains. What should we do with the time we have? For most of this journey, we have looked outward, toward stars, toward galaxies, toward black holes. toward the vast structures that shape the history of the cosmos. But now, as we approach the farthest reaches of time, it is worth asking a different question. What was the significance of all of it? Why did the universe spend billions of years creating stars? Why did galaxies form? Why did planets emerge? Why did life appear? And perhaps most importantly, was any of it meaningful? From the perspective of the universe, humanity appeared only moments ago. If the entire history of the cosmos were compressed into a single year, modern civilization would occupy only the final seconds before midnight on December 31st. Our lives are brief, our civilizations fragile, our existence temporary. And yet, within that brief moment, something extraordinary happened. The universe became capable of asking questions about itself. For billions of years, stars burned without understanding their own existence. Galaxies collided without awareness. Black holes grew in silence. The cosmos evolved according to the laws of physics. But eventually, on at least one small planet orbiting one ordinary star, matter organized itself into something new. Consciousness, the ability to observe, to wonder, to imagine, to understand. In many ways, this may be one of the rarest phenomena the universe has ever produced. The emergence of minds capable of reflecting on reality itself. When humans look at the stars, something remarkable occurs. The universe studies itself. Atoms forged inside ancient stars come together to contemplate their own origins. The carbon in our bodies was created billions of years ago in stellar furnaces. The oxygen we breathe was born inside dying stars. The calcium in our bones was forged in cosmic explosions. We are not separate from the universe. We are part of it, a temporary arrangement of matter that became aware. And while individual lives are brief, the knowledge we create can endure. Each generation builds upon the discoveries of those who came before. Ideas travel across centuries, across civilizations, across continents. A single insight can outlive empires, perhaps even entire worlds. Imagine a future civilization surviving long after Earth is gone. Perhaps humanity spreads beyond the solar system. Perhaps entirely new forms of intelligence emerge. Perhaps minds exist around distant stars trillions of years from now. The details remain unknown, but the possibility is profound. The story of consciousness may continue long after our own chapter ends. And even if intelligent life eventually disappears, its existence would still matter. Because for a brief moment, the universe was not merely existing, it was being experienced. There were sunsets, there was music, there was curiosity, there was love, there was wonder. The stars illuminated worlds where living beings could gaze upward and ask questions. That alone makes this era unique. When we think about the distant future, it is easy to focus on endings. The death of stars, the disappearance of galaxies, the evaporation of black holes. But perhaps the more remarkable story is that any of it existed at all. Against unimaginable odds, the universe produced complexity, it produced beauty, it produced life. And somewhere along the way, it produced observers. Observers capable of appreciating the story. Perhaps meaning is not something hidden within the universe, waiting to be discovered. Perhaps meaning is something created. Created whenever a conscious being experiences reality. Created whenever curiosity overcomes ignorance. Created whenever knowledge expands. Created whenever someone looks at the night sky and wonders what lies beyond. In that sense, meaning may be one of the most extraordinary things the universe has ever generated. Not because it lasts forever, but because it exists at all. As we approach the final stage of our journey, the scale of time becomes almost impossible to grasp. Trillions of years, quadrillions, numbers so vast that entire cosmic ages appear insignificant. Yet no matter how large those numbers become, they cannot erase the fact that this moment happened. that stars existed, that planets formed, that life emerged, that consciousness appeared. The future may be endless, but the past remains part of the story forever. And perhaps that is enough, because even in a universe destined for darkness, there was once light. Even in a universe destined for silence, there were once voices. Even in a universe destined for emptiness, there was once life. The cosmos may continue changing long after everything familiar has vanished, but nothing can undo the journey that brought it here. Nothing can erase the billions of years that transformed a hot, primordial universe into a place capable of understanding itself. And as we move into the final chapter, one last mystery remains. Not about stars, not about galaxies, not about black holes, but about existence itself. The deepest mystery of all. Why is there something rather than nothing? And is that question destined to remain unanswered forever? For as long as humans have existed, we have looked toward the future and wondered how long our story might continue. Will humanity survive the coming centuries, the coming millennia, the coming millions of years? Or will we eventually disappear, joining the countless species that once lived on Earth and are now forgotten? The answer remains unknown. But if humanity survives long enough, the future that awaits may be stranger than anything our ancestors could have imagined. Tonight, we journey beyond the fate of stars and galaxies to explore a different question. Not the future of the universe, but the future of us. At this moment in history, humanity is still a young species. Modern humans have existed for only a few 100,000 years. Civilization itself occupies only a tiny fraction of that time. Compared to the age of Earth or the age of the universe, humanity has barely begun its story. And yet, in that brief period, we have transformed the surface of an entire planet. We have built cities, crossed oceans, split the atom, walked on the moon, and sent machines beyond the solar system. The pace of progress has been extraordinary. But what happens next? If humanity survives its current challenges, the coming centuries may witness transformations greater than all previous history combined. Artificial intelligence may become increasingly powerful. Biotechnology may allow us to modify our own biology. Machines may merge with minds. The distinction between human and technology could gradually disappear. Future generations may look very different from us, not because evolution changed them, but because they changed themselves. Throughout most of history, evolution was guided by nature, random mutations, natural selection, environmental pressures. But intelligent beings possess a unique ability. They can direct their own development. For the first time in Earth's history, a species may gain control over its own evolution. Imagine humans capable of eliminating disease, extending lifespan, enhancing memory, increasing intelligence, or adapting themselves to environments beyond Earth. The possibilities are extraordinary, and they may represent only the beginning, because eventually humanity may face a challenge greater than any technological problem: the limits of Earth itself. Our planet will not remain habitable forever. As the sun slowly grows brighter over billions of years, Earth's environment will become increasingly hostile. Long before the sun becomes a red giant, life on Earth may become impossible. If humanity wishes to survive, it cannot remain on a single world forever. It must expand. The first steps may occur within our own solar system: permanent settlements on the moon, cities beneath the surface of Mars, habitats orbiting distant planets, entire communities living in artificial worlds built in space. To us, such visions may sound futuristic, but compared to cosmic timescales, they could happen remarkably soon. And once humanity becomes a multi-planet species, an even greater frontier awaits: the stars. The distance between stars is immense. Light itself requires years to travel from one system to another, yet the universe is vast beyond imagination. Hundreds of billions of stars exist within the Milky Way alone. Many possess planets. Some may possess environments suitable for life. If humanity develops advanced propulsion systems, interstellar travel may eventually become possible. The first voyages could take generations, entire communities living aboard enormous spacecraft, traveling for centuries between the stars. Future explorers may never see Earth, their entire lives unfolding during the journey. For them, the spacecraft itself would be home. And beyond those first journeys lies the possibility of a galactic civilization. A civilization spread across thousands of star systems, perhaps millions. A civilization so vast that individual worlds develop unique cultures, histories, and identities. Humanity would no longer be confined to a single planet, or even a single star. It would become a cosmic species. Het expansion alone does not guarantee survival. New dangers emerge with every advance. Technology becomes more powerful. Civilizations become more complex. The risks become greater. History demonstrates that intelligence can create extraordinary achievements, but it can also create extraordinary threats. Future civilizations may face challenges we cannot yet imagine: conflicts, accidents, uncontrolled technologies, environmental catastrophes, or dangers arising from entirely new forms of existence. The future is filled with opportunities, but also uncertainties. And perhaps the greatest uncertainty concerns the nature of humanity itself. If technology continues advancing, future descendants may become fundamentally different from us. Their bodies may change, their minds may change. Some may choose biological forms. Others may exist primarily within digital environments. Consciousness itself may take forms beyond anything currently possible. Would such beings still be human? The answer depends on how we define humanity. Is it our biology, our appearance, our memories, our consciousness, or something deeper? Over millions of years, the distinction may become impossible to answer. Humanity could evolve into countless branches, some biological, some artificial, some existing in environments where no human could survive today. The descendants of humanity may become as different from us as we are from our earliest ancestors. Yet all of them would share the same origin: a small world orbiting an ordinary star. As the ages pass, civilizations rise and fall. Stars are colonized, new worlds are settled, entire regions of the galaxy become inhabited. For a time, it may seem that humanity has conquered its destiny, that intelligence has overcome the limitations imposed by nature. But the universe remains larger than any civilization. Stars still die. Galaxies still evolve. Time still moves forward. No matter how advanced a civilization becomes, it cannot escape the fundamental laws of the cosmos. Eventually, even the grandest civilizations must confront the future of the universe itself. The death of stars, the fading of energy, the approach of cosmic darkness. And so, we arrive at a profound possibility. Perhaps there will come a day when only a few descendants of humanity remain, scattered among the final stars, living in a universe far older than the one we know today. Guardians of knowledge accumulated across trillions of years, witnesses to the closing chapters of cosmic history, the last humans. Or perhaps by then, they will no longer call themselves human at all. Yet regardless of their form, they will carry something remarkable, a legacy that began on Earth, a legacy of curiosity, of exploration, of asking questions about the universe and our place within it. That legacy may survive far longer than any civilization, far longer than any planet, perhaps even far longer than the stars themselves. Because while worlds may disappear and galaxies may fade, the desire to understand may be one of the most enduring traits ever produced by the cosmos. And as we continue our journey into the distant future, another question emerges. If intelligence survives for trillions of years, can it survive forever? Or will even the greatest civilizations eventually reach their limits? That is the story of our next chapter. For billions of years, intelligence may spread across the stars. Civilizations may rise, worlds may be transformed. Knowledge may accumulate beyond anything we can imagine today. The descendants of humanity may colonize countless systems, master technologies that seem impossible to us, and survive challenges that would destroy civilizations in our own era. Yet a question remains. Can intelligence survive forever? At first, the answer may seem obvious. Why not? If a civilization becomes advanced enough, perhaps it can overcome every obstacle, every disease, every natural disaster, every technological challenge. Perhaps intelligence can simply continue adapting indefinitely. But the deeper we explore the laws of physics, the more complicated the question becomes. Because intelligence does not exist in isolation. It depends on energy. Every thought requires energy. Every memory requires energy. Every computation requires energy. Every civilization depends on the ability to perform work. And the universe places limits on all of these things. Imagine a civilization trillions of years in the future. The stars are becoming increasingly rare. Most sources of energy have already been exhausted. The cosmos is colder and darker than ever before. Yet intelligent beings still survive. Their technology allows them to harvest energy with extraordinary efficiency. Nothing is wasted. Every resource is carefully managed. Every decision is optimized for survival. For a time, such a civilization may continue thriving, but physics imposes a difficult reality. The amount of usable energy in the universe is not infinite. Over vast timescales, energy becomes increasingly dispersed, less concentrated, less accessible. The universe moves toward greater entropy, toward greater disorder. This creates a profound challenge. As usable energy declines, intelligence must become increasingly efficient. Civilizations may slow their activities. Computations may become less frequent. Thought itself may become precious. Imagine a future society where a single conversation is separated by centuries. Not because communication is difficult, but because conserving energy has become essential. A civilization where minds enter long periods of dormancy, awakening only occasionally to exchange information before returning to sleep. To us, such an existence would seem almost motionless. Yet from their perspective, it may be the only way to survive. As the universe continues aging, even more difficult questions emerge. How much information can be stored? How much knowledge can be preserved? Can memory itself survive forever? Every civilization accumulates information, scientific discoveries, historical records, works of art, personal experiences, entire libraries of knowledge. But storage requires physical systems. Physical systems are vulnerable. They decay, they fail, they require maintenance. Even the most advanced technology cannot escape the laws of thermodynamics. Over sufficient time, preserving information becomes increasingly difficult. Some physicists have suggested that the ultimate limit of intelligence may not be energy alone. It may be memory. A civilization can only remember so much, only process so much, only preserve so much information before confronting fundamental physical limits. Imagine a civilization that has existed for trillions of years. Its archives contain more knowledge than entire galaxies once possessed. Its history stretches beyond comprehension, yet eventually, difficult choices must be made. What should be preserved? What should be forgotten? Which memories deserve to survive? Which stories must be allowed to fade? In this distant future, forgetting may become as important as remembering. And there is another challenge: complexity. As civilizations grow larger and older, they become increasingly complicated. Networks expand, Systems multiply, dependencies accumulate. Maintaining stability becomes harder. Even today, complex systems can fail unexpectedly. Future civilizations may face similar risks on far greater scales. A single error, a cascading failure, an unforeseen consequence. Over cosmic timescales, even extremely unlikely events become inevitable. The longer a civilization survives, the greater the opportunity for something to go wrong. This raises a sobering possibility. Perhaps intelligence does not end through violence. Perhaps it does not end through catastrophe. Perhaps it simply becomes impossible to sustain indefinitely. Not because civilization lacks knowledge, but because the universe itself gradually removes the conditions that make intelligence possible. The stars fade, energy declines, resources disappear, the environment becomes increasingly hostile. And yet, intelligent beings may refuse to surrender. Throughout history, life has repeatedly adapted to changing circumstances. The descendants of humanity may do the same. They may shrink their energy requirements, transfer consciousness into new forms, create minds vastly more efficient than biological brains. Entire civilizations could exist within structures smaller than cities, smaller than mountains, perhaps even smaller than planets, computing more efficiently than anything we can currently imagine. For a time, such strategies may succeed, for billions, trillions, even quadrillions of years. But eventually, every solution encounters the same challenge. The universe continues evolving, entropy continues increasing, the supply of usable energy continues shrinking, the horizon continues approaching. Some physicists believe that intelligence may persist astonishingly far into the future, far beyond the lifespan of stars, far beyond the age of black holes. Yet even they acknowledge a difficult truth. Forever is an extraordinarily long time, and surviving forever may require more than intelligence alone. It may require new physics, new discoveries, new possibilities that we have not yet imagined. Perhaps future civilizations will uncover solutions hidden beyond our current understanding. Or perhaps they will eventually confront an unavoidable limit, the final boundary imposed by reality itself. And that leads us to one of the most haunting possibilities in the entire future of the universe. Imagine the last civilization, the final community of conscious beings, the last surviving observers in existence. A civilization that has endured longer than stars, longer than galaxies, longer than black holes. A civilization standing alone at the edge of cosmic history. What would they see? What would they remember? And what would happen when they finally disappear? That is the story of our next chapter, the story of the final observer. Imagine a universe where only one conscious mind remains, one final observer, one last witness to existence itself. For billions of years, intelligence spread across the cosmos. Civilizations rose and fell, stars were colonized, knowledge accumulated, entire galaxies became home to countless forms of life. The universe once echoed with activity, with discovery, with curiosity. But time is patient, and time eventually claims everything. The stars disappeared, the planets vanished, the galaxies grew dark. One by one, civilizations reached their limits. Some faded quietly, others transformed into forms beyond recognition. A few endured for unimaginable spans of time. Yet even the greatest civilizations could not escape the future forever. Now, only one remains, the final observer. We do not know what this being would look like. Perhaps it would no longer resemble a human. Perhaps it would not even possess a physical body in any familiar sense. It could be biological, artificial, or something entirely different. The result of trillions of years of evolution and adaptation. A mind shaped by an ancient universe. A mind carrying the accumulated knowledge of countless generations. Imagine the memories such a being might possess, the history of worlds long vanished, the stories of civilizations forgotten for trillions of years, records of stars that no longer exist, galaxies that have faded beyond recognition. To the final observer, the age of stars would seem as distant as the formation of Earth seems to us today, ancient history, almost mythological. And yet, those memories may be all that remain, because by now, the universe itself has become nearly empty. No bright suns illuminate the darkness, no planets circle distant stars, no civilizations exchange messages across space. The cosmos has become vast beyond comprehension and almost completely silent. The final observer drifts through this ancient reality, perhaps surrounded by advanced technologies designed to prolong existence, perhaps existing within a carefully preserved structure powered by the last available sources of energy. Every resource is precious, every calculation matters, every thought has a cost, because energy has become the rarest commodity in the universe. Long ago, civilizations consumed the power of stars. Later, they harvested the energy of black holes. But those ages have ended. The remaining supply grows smaller with every passing era. The final observer understands this better than anyone. They know that existence itself has become fragile, and still they continue. Perhaps out of curiosity, perhaps out of hope, or perhaps simply because they always have. Imagine looking out across the universe during this era. There are no familiar landmarks, no glowing galaxies, no nearby stars, only darkness stretching endlessly in every direction. The night sky, if it could still be called a night sky, would appear almost empty. A few faint particles, a few distant traces of radiation, the final echoes of a once vibrant cosmos. To most minds, such a universe would seem lonely, but loneliness requires the possibility of companionship. The final observer may have existed alone for longer than entire cosmic ages, long enough that solitude itself has become normal, long enough that the memory of others feels like a message from another reality. And yet, even now, questions remain. The same questions that have followed intelligent beings since the dawn of consciousness. Why does the universe exist? What came before it? What lies beyond it? Some mysteries survive longer than stars, longer than galaxies, longer than civilizations. Perhaps the final observer continues searching for answers, performing experiments, analyzing data, exploring the deepest laws of reality, refusing to surrender curiosity, even at the end of time. Because curiosity may be one of the last things left, one of the last fires still burning in an increasingly dark universe. But eventually, another problem emerges: memory. The longer a mind exists, the more experiences it accumulates, the more history it carries, trillions upon trillions of years of knowledge, countless observations, countless discoveries. Can any mind contain so much information forever? Perhaps not. The final observer may eventually face impossible choices. Which memories should be preserved? Which should be forgotten? Entire civilizations may survive only as fragments. Entire histories reduced to brief summaries. Even memory must compete for limited resources. Even the past cannot escape the laws of physics. And then comes the ultimate challenge. The supply of usable energy approaches exhaustion. There is no new source waiting to be discovered, no hidden reservoir capable of restoring the cosmos. The universe has grown old, very old. The final observer understands what this means. The calculations are clear. The future contains fewer opportunities, fewer thoughts, fewer moments of awareness. Existence itself is becoming increasingly difficult to sustain. Perhaps the final observer chooses to slow their thoughts. A single idea every million years, a single memory reviewed every billion years, stretching consciousness across unimaginable spans of time, trying to survive a little longer, trying to witness a little more, trying to remain present as the universe approaches its final stillness. And eventually, the moment arrives. The last reserve of usable energy, the final computation, the final observation, the final thought. No catastrophe occurs, no explosion, no dramatic ending, only silence. The final observer ceases to exist. For the first time since consciousness first emerged in the cosmos, there are no observers left. No minds, no memories, no questions. The universe continues, but no one remains to witness it. The stars once illuminated countless worlds. The galaxies once contained countless civilizations. The cosmos once overflowed with life and possibility. Now, all of it belongs to history. And history itself has ended. Or has it? Because even this may not be the final chapter. Some theories suggest that new universes may emerge, new beginnings may arise, new observers may one day open their eyes beneath unfamiliar stars. Perhaps the death of the last observer is not the end of consciousness. Perhaps it is merely the end of one cosmic story. And if that is true, then somewhere beyond the darkness, beyond time, beyond everything we currently understand, another observer may one day ask the same question humanity once asked beneath the stars. How did it all begin? For most of this journey, we have followed a single timeline. A universe born in a Big Bang, a universe that formed stars, created galaxies, produced life, and eventually faded into darkness. But what if this story is incomplete? What if the end of our universe is not truly an ending? What if it is a beginning? For centuries, humans viewed the universe as a one-time event, a cosmic story with a clear starting point and a clear ending. The Big Bang marked the beginning. The future would eventually bring the conclusion, simple, elegant, final. Yet modern physics has revealed that reality may be far stranger. Some theories suggest that our universe may not be unique. Others suggest that universes can be born repeatedly, again and again, across unimaginable spans of time. If these ideas are correct, then the death of our universe may not be the end of existence. It may simply be one chapter in a much larger cosmic cycle. To understand this possibility, we must return to the beginning. Nearly 14 billion years ago, our observable universe emerged from an extremely hot and dense state. Space expanded, matter formed, the first stars ignited. Everything we know today traces its origin back to that event. Yet one mystery has always remained. What caused the Big Bang? What happened before it? The honest answer is simple: we do not know. And it is within that uncertainty that some of the most fascinating ideas in cosmology emerge. One possibility is known as the Big Bounce. According to this idea, our universe may not have begun from absolute nothingness. Instead, it may have emerged from the collapse of a previous universe. Imagine a cosmos expanding for trillions upon trillions of years. Eventually, conditions change. Expansion slows. Gravity begins reclaiming control. The universe contracts. Galaxies move closer together. Temperatures rise. Matter becomes increasingly compressed. The entire cosmos collapses inward. Then, rather than ending in a final singularity, a bounce occurs. A new expansion begins. A new universe is born. A new cosmic history unfolds. In this scenario, the Big Bang was not the beginning of everything. It was simply the latest beginning. One cycle among many. An endless sequence of cosmic deaths and rebirths stretching across eternity. No first universe, no final universe. Only an infinite rhythm of creation and destruction. Another possibility emerges from quantum mechanics, the strange theory that governs the smallest scales of reality. According to quantum physics, empty space is not truly empty. Fluctuations constantly appear within the vacuum. Tiny regions of space briefly gain energy before returning to equilibrium. Most of these fluctuations are insignificant, but over unimaginable periods of time, something extraordinary may occur. A fluctuation large enough to create an entirely new universe, a new bubble of expanding space, a new Big Bang, a new cosmos with its own stars, galaxies, and history. To observers inside that universe, it would appear completely independent. Its inhabitants might never realize they originated from a fluctuation within another reality. Their universe would seem complete, self-contained, just as ours appears today. This idea leads to an astonishing possibility. The universe may be constantly giving birth to new universes, an endless cosmic family tree stretching far beyond anything we can observe. And then there is the concept of eternal inflation, one of the most influential ideas in modern cosmology. According to this theory, the rapid expansion that occurred shortly after the Big Bang may never have completely stopped. Instead, some regions of space continue inflating forever. Occasionally, pockets of that inflating space stop expanding and form individual universes. Each pocket becomes its own cosmos, its own Big Bang, its own reality. Meanwhile, the larger process continues indefinitely, creating more universes and more without end. In this picture, our universe becomes one bubble among countless others, perhaps millions, perhaps trillions, perhaps infinitely many, each with different properties, different histories, different possibilities. Some may contain stars and galaxies, others may be sterile and empty. Some may follow physical laws radically different from our own. The multiverse becomes a vast ocean of realities, each one representing a different expression of what is possible. These ideas remain speculative. We do not yet possess evidence capable of confirming them. Yet they reveal something important. The universe may be far larger than our observable horizon suggests, far more complex, far more mysterious. The ultimate future of reality may not involve a single ending at all. Instead, endings and beginnings may coexist. One universe dies, another is born. A cosmic cycle unfolding across scales beyond imagination. If that is true, then the final observer of one universe may not witness the final observer of existence. Because somewhere else, beneath another set of stars, another story may already be beginning. Another civilization may emerge. Another species may gaze upward and wonder about its origins. Another mind may ask questions about the nature of reality. The same questions we ask today. And perhaps they too will discover that every ending contains the possibility of a beginning. That every death creates the conditions for something new. That the universe, in one form or another, may be endlessly creative, endlessly transforming, endlessly becoming. The idea is both humbling and beautiful, because it suggests that existence may be larger than any single universe, larger than any single history, larger than any single ending. And yet, even if new universes are born forever, one profound mystery remains. What lies beyond all of them? Beyond every universe, beyond every dimension, beyond space itself, beyond time itself. To explore that question, we must travel beyond the very foundations of reality, beyond space and time. That is where our journey continues next. Throughout this journey, we have spoken about stars, galaxies, black holes, civilizations, even entire universes. But all of these things share something fundamental. They exist within space and time. Every event we have explored occurred somewhere, and every event occurred sometime. Space and time form the stage upon which the story of the cosmos unfolds. Yet modern physics has revealed a startling possibility. Space and time may not be fundamental at all. They may be emergent, temporary. perhaps even illusions arising from something deeper. To understand this possibility, we must first confront a difficult question. What is time? At first, the answer seems obvious. Time is what clocks measure. It moves from past to future, second by second, year by year. We experience it every moment of our lives. Birth, growth, aging, memory, all appear to depend on the flow of time. And yet, when physicists examine the deepest laws of nature, something strange emerges. Many of the fundamental equations work equally well forward and backward. The laws themselves often make no distinction between past and future. From the perspective of physics, time appears far less special than our experience suggests. This creates a profound mystery. Why do we remember the past, but not the future? Why does time appear to flow in one direction? The answer may lie in entropy, the gradual increase of disorder throughout the universe. As entropy increases, events become irreversible. A broken glass does not spontaneously reassemble. Smoke does not return to a candle. The universe develops an arrow of time, a direction from order toward disorder. But even this may not fully explain what time actually is. Some physicists have proposed an extraordinary possibility. What if time does not flow at all? What if the past, present, and future all exist simultaneously? Imagine a book. Every page exists at once, yet a reader experiences the story page by page. Perhaps reality functions in a similar way. The entire history of the universe already exists, from the Big Bang to the far future. And our consciousness simply experiences one moment after another as it moves through that structure. In such a universe, time would not be flowing, we would be. The idea sounds strange, yet versions of it emerge naturally from Einstein's theory of relativity. According to relativity, time is not universal. Different observers experience it differently. Two people moving at different speeds can disagree about the passage of time. Clocks tick at different rates depending on gravity. Time stretches. Time bends. Time is woven together with space itself. Together they form a single structure known as space-time. For more than a century, relativity has transformed our understanding of reality. But it may not be the final answer. Because when physicists attempt to combine relativity with quantum mechanics, the picture begins to break down. At the smallest scales, reality behaves in ways that challenge our intuition. Particles exist in multiple states simultaneously. Events become probabilistic. Certainty disappears. And within some approaches to quantum gravity, time itself begins to vanish from the equations. Not slow down, not bend, disappear entirely. The mathematics still works, yet time is nowhere to be found. This has led some physicists to wonder whether time is not fundamental. Perhaps it emerges from deeper relationships hidden beneath reality. Much like temperature emerges from the motion of atoms. Temperature feels real, yet it is not fundamental. It arises from something deeper. Time may be similar, an emergent property generated by structures we do not yet understand. And if time is emergent, what about space? Surprisingly, the same question applies. Modern theories suggest that space itself may emerge from more fundamental ingredients. The distances we measure, the dimensions we experience, the geometry of the universe, all may arise from deeper layers of reality. Some theories describe networks of information. Others describe quantum connections linking distant regions together. Still others suggest that space itself emerges from patterns of entanglement. In these models, space is not the foundation of reality. It is a consequence of something deeper, something more fundamental. Imagine discovering that the universe is not built from matter, not built from energy, not even built from space and time, but from information, relationships, mathematical structures beyond ordinary experience. Such ideas remain speculative, Yet they represent some of the most active areas of modern theoretical physics, and they lead to an astonishing conclusion. The reality we experience may be only one layer of a much deeper structure, a structure hidden beneath everything we know. If that is true, then questions about the beginning of the universe become even more complicated. What existed before space? What existed before time? The answers may not involve a before at all. Because if time itself emerged from a deeper reality, then the concept of before may lose its meaning, just as north disappears at the North Pole. Certain questions may simply no longer apply. And yet, human curiosity continues asking them, continues pushing beyond the limits of knowledge, beyond the limits of observation, beyond the limits of imagination, because there is something deeply human about seeking what lies beyond the horizon, even when the horizon itself may be an illusion. Perhaps one day, future civilizations will uncover the true nature of space and time. Perhaps they will discover the deeper framework from which reality emerges. Or perhaps the ultimate foundation of existence will remain forever beyond reach. A mystery hidden beneath every mystery, the final horizon, the deepest question. And if there truly is a reality beyond space and time, then everything we have explored throughout this journey may be only a small part of a much larger story. A story extending beyond universes, beyond dimensions, beyond beginnings and endings. A story whose true nature remains unknown. And that brings us to the final chapter. Not a chapter about the future, not a chapter about physics, but a chapter about meaning, about perspective, about what all of this may tell us about our place in the cosmos. After traveling from the birth of the universe to the end of time, one final question remains. What does it all mean?